The following is a tutorial on doing specific heat calculations. Okay, we're going to start with a fairly easy one where we're just going to be calculating Q, which is the amount of energy. So graphite has a specific heat of 0.709 joules per gram degree Celsius. If a 25 gram piece of graphite is cooled from 35 degrees Celsius to 18 degrees Celsius, how much energy was lost by the graphite? Okay, so the nice thing about all these chemistry problems is we have units next to all of the numbers to indicate what they are. So we know that specific heat is the amount of energy required to change 1 gram of a substance by 1 degree Celsius. So here we have C, specific heat. We have the mass. It says 25 grams. We know grams is a measure of mass. And it's cooled from 35 degrees Celsius to 18 degrees Celsius. So if we're going from 35 to 18 degrees Celsius, that means that this is our initial temperature and this would be our final temperature. Okay, we're going from 35 to 18. And the question asks, how much energy was lost? Okay, so if we're cooling a substance, that means we're losing energy. So we should be ending up with a negative Q value. All right, so let's go ahead and outline the information. We know we are looking for the amount of energy. We've got the mass, which is 25 grams. We have specific heat, 0.709 joules per gram degree Celsius. And then change in temperature, we're going to do the final temperature minus the initial. So 18 degrees Celsius minus 35 degrees Celsius, and you will get negative 17 degrees Celsius. Okay, so notice our energy units in the specific heat value is joules, so my answer is going to end up in joules. Okay, the question does not indicate what unit of energy you need to end up with. We're given mass in grams, the specific heat is also given in grams, and then the temperature is given in Celsius, okay, and the specific heat calls for Celsius. So we don't need to do any unit conversions. We can just go ahead and start plugging in the information. So we have Q equals MC delta T. All right, so Q equals, I'm going to go ahead and plug these in with the units because it's going to be a little bit easier to see how they cancel out. Oops. Right, and then our change in temperature is negative 17 degrees Celsius. Okay, so we can see already we've got grams on the top here, grams is on the bottom here, so those units are going to cancel. You're given Celsius down here, Celsius right here, so those units cancel. And the unit that we're going to end up with is joules. Okay, and since we are looking for the amount of energy, that means that we plugged everything in correctly. So 25 times 0.709, okay, we're just multiplying all these values, times negative 17, and you'll get negative 301.325. So let's just round that to negative 301. Remember, we said that the unit that we end up with is joules. If we were going to use significant figures for this problem, the least accurate measurement has 2 sig figs. So I'm going to go ahead and round that. So we're going to get negative 3.0 times 10 to the 2 joules. All right, let's try another problem. Okay. An unknown substance with a mass of 100 grams, okay, 100 grams, so that's our mass, absorbs 1.00 kilojoules while undergoing a temperature increase of 15 degrees Celsius. What is the specific heat of the substance in joules per gram Kelvin? Okay, so let's outline our information. All right, so it absorbs 1.00 kilojoules we are given the mass of 100 grams. There's a temperature increase of 15 degrees Celsius. So in this problem, instead of giving a final and an initial temperature, it tells you how much the temperature changed. Okay, and if there only is one value for temperature, just pay attention to the question. If it says what is the initial or what is the final temperature, then this is not your delta T. Okay, in this case, it's asking for specific heat, so this is the change in temperature. So delta T equals 15 degrees Celsius. And the specific heat is wanted to be in joules per gram Kelvin. Okay, so we're going to have a few unit conversions here. So first of all, we are given the amount of energy in kilojoules, but the question calls for joules. So we're going to convert that. So 1.00 kilojoules. Okay, there are 1,000 joules in 1 kilojoule. So we're just going to multiply. So 1 kilojoule is equal to 1,000 joules, so that's going to be our value for Q. Okay, the mass units are grams, so we're good there. But the specific heat calls for Kelvin, and you're given the temperature in Celsius. So to go from Celsius to Kelvin, Kelvin equals degrees Celsius plus 273. Okay, so we're just going to add 273. And you will get 288 Kelvin. Okay, now we're going to be able to plug all these values in. Okay, so we wanted joules for our energy units, we wanted grams for our mass units, and then Kelvin for our temperature units. So Q equals MC delta T. Okay, remember that we are looking for C, so that's our unknown. Let's go ahead and just call that X when we plug it in. Okay, so Q is 1,000 joules. The mass is 100 grams. We're looking for C. And then our change in temperature is 288 Kelvin. Sorry about that. Okay, so the first thing we can do is go ahead and simplify this. So let's combine the terms that we can combine. So if we're going to do 100 times 288, okay, and since we're multiplying grams times Kelvin, that's grams times Kelvin. And that is multiplied by x. So we did 100 times 288 times x. And I'm going to go ahead and put x on the end. All right, and then we have 1,000 joules over here. All right, we're trying to get x by itself. So since we've got 28,800 times x, we're going to go ahead and do the opposite to get rid of it. So if this is multiplication, I'm going to divide both sides by 28800. All right, brought my units with me. All right, and I'm going to get an answer of 0.0347. And that's joules divided by grams Kelvin. Let's go ahead and correct this for significant figures. We've got 1 sig fig, so my answer will be 0.03 joules per gram Kelvin. All right, and really quickly I'll show you how to do that calculation without the units, so maybe that will be a little bit easier for you guys to see the math. So we've got 1,000 equals 100 times our unknown times 288. Okay, so this is Q, M, delta T, and we're looking for C. So just like before, we'll combine these terms. So 100 times 288. Right, so I just combined them, and since we're used to seeing the variable at the end, that's where I stuck that. And now we're just going to divide both sides by this number so that we can get x by itself. And you'll get the same answer, 0.0347. Okay, I do highly recommend that you include the units when we're doing the calculations. That way you'll know if you missed any unit conversions from the beginning of the problem, and it will help you see what units that you need to end up with. So in this case, we did know that the question called for joules per gram Kelvin.